Um, so if you come here, we go to chapter 5 STP, spanning 3 protocols. I'll try to make it very simple for you. So STP is about when you have a lot of switches interconnected, we need to elect the big boss, the master, and the other one are, let's say, the slaves. So the master or the manager of that team will send instructions, directives to the employees. That's all, nothing else. So first thing first, I have many switches interconnected. When we all, let's say I have 4 or 5, it's a team. We need a manager, a big boss. We call it the root bridge. When he's elected, now any others are the employees. We need to grab instructions from him. That's all, nothing else. So now, based on what the manager will be elected, it's where we're going to. If we don't elect a manager, everyone will do whatever we want to do. No one is accountable to anyone. But at least if you have some rules, uh, some guidelines, a team leader or a manager, at least we have. So if you don't have STP, so STP is a program that will automatically, let's say, elect the manager or the root bridge. You see, so it's a program that will allow so that we won't get chaos. Because if you have chaos, it's going to bring your network down. So STP is going to regulate the traffic between all these switches. If you understand that, that's all for this chapter. Nothing else. So you see here, a layer to loop create a similar chaos in the network. It can very happen quickly, and we got that when I was working in Pretoria in 20, I even forgot, 2012. It brought the whole network down, boom. So it's very, very important. So there are a few common ways that a layer 2 loop can be created and propagated. Spanning tree protocol is designed specifically to eliminate layer 2 loops in your network. That's why always before you start a chapter, it's good to start from here. Why should I take this? So now that we know where we go, let's go. The purpose of yeah, I think it's the same thing here. So you see here, you have three switches interconnected. If there is no rules, everyone will send whatever, block what you see, and with traffic, the network is down. So we need to indicate who is the manager, the big boss, and anyone else will take instructions from that boss. You see, it's like on the traffic, you have these police guys. If all the traffic lights are totally off and no one wants to obey the rules, you see, but at least if there is a guy there, you say, okay, you guys stop, the other guys go. You see, it will be same thing. So now, based on what, so we have some rules to manage all of these. You see, it's what we're going to do to study. So I want to make it very simple for you. So if there is no rules, everyone will start flooding, sending, whatever. Now, based on what is the broadcast on chaos, everyone is stopped. Trucks are blocking the road. See, we have. So now we need this program, this algorithm, this system, and to regulate like the traffic light. When you have traffic lights, then if there is no traffic light, you see the chaos that will get. So with spanning tree protocol, it's like a traffic light on road. You see a lot of switches. In case you have a lot of switches interconnected, this one is normally it's when the company is very big. Then you can use you can get these things. So we need some rules. If it's green, you go. If it's red, you stop. The same thing like here. So this is something we need to elect the big boss. We call it the root bridge. You see, when the root bridge is elected, anyone else is what? Employees, and will take direction, instructions from the big boss, the root bridge. So we have some rules to elect this guy. We're going to check that later. So as I said, I want to make it very simple for you. After that, when this guy is elected, on other ports, on other switches, they need to get some port that will be blocked. We won't be allowed to send traffic. It's the rules. We're going to check the rules soon. So if this guy is elected, he's going to say now, okay, other guys, I need you to get one of your ports blocked. You must not. If everything is open and everyone is sending via all ports, it will be chaos. So we're going to reduce traffic. So some port will be blocked. We get to the rules. We go to the rules. Then when everything is well done, the big boss is elected, some ports are blocked. Now the traffic will flow nicely. So you have a video that will explain all these. The 6-minute video. So it will explain properly what is spanning tree, how the big boss is elected, how people, how other switches will get some port blocked. This video will explain everything. I'm trying to make it simple for you. We'll get some labs, very, very important labs. I'm going to show you one. Oh, no, it's not here. Okay, I'll try to find it for you later. Okay, you can check your quiz, submit. Now, operations. Operation, what are the rules? You see, now that you know how loops are created, if there is no traffic light, there is no police guy with traffic cops, everyone will be doing anything. It will be chaos loops and can bring the network down. So to avoid that, we need some rules. So now that you know how loops are created and the basics of using spanning tree protocol to prevent them, this topic will take you step by step through the operation of STP. So to avoid, to get a loop-free topology or environment, first thing first, we need to elect the root bridge. How to elect it, we're going to check soon. Step number 2, on other switches, we need to get what we call a root port. We'll see what is the root port, how we are elected. Step number 3, we're going to elect designated port. Then we'll see the blocked ports. So these are the 4 steps we need to put in place to get a loop-free topology. No accident, no traffic, everything's clean. When it's red, you stop. When it's green, you see, everyone obeys the rules. It's the same thing. So now, there is something called, because all these guys, all these switches, they need to share informations. Someone will say, for example, okay, me, my my student number is 111. The other one will say, okay, me, my student number is 777. The other one will say, okay, me, my student number is 333. Now the rules will say, okay, the student with the highest student number or the lowest student number will be elected your team leader. You see. So here for the switches, instead of student number, it will be such thing. The bridge priority. There is a number. We check that first. So we're going to do some examples now. So no worries. So everyone will share his student number. Then the rule will say something. So you see here, for example, we switch as a bridge ID. So a bridge ID is the combination of priority and MAC address. We call it the bridge ID or student number. We're going to share that between themselves. So by default, this is the priority. You can change it. So this one, switch 3 will say, okay, this is my student number. Switch 1 will say, okay, this is my bridge ID or my student number. Switch 2 will say, okay, me, this is my bridge ID or my student number. Now, what next? What next? The switch with the lowest bridge ID will become the root bridge. So the student with the smallest or the lowest, I don't know, student number will be your team leader. So when you have all the bridge IDs, to compare them, you start with the priority. We say the lowest. We start 3279. Here's 32,000, so 32,000 something, and here is 24,000 something. So the priority here is the lowest. So automatically, switch 1 become the big boss, the manager, or the team leader of the team of 3. If they got the same priority, then we go down to the MAC address. We go down to the MAC address. So now we have 3 switches interconnected. We need to put STP in place to avoid loops. First thing first, we need to elect what? The root bridge, the big boss. The switch with the lowest bridge ID will become the root bridge. What will be second step? Okay. So you see here, for example, they have the same priority. So if they all have the same priority, now we go down to compare the MAC addresses and we take the lowest MAC addresses. So you see here, for example, is 000A, here 000A, here 000A. Okay, we all match. Now we go next. 0022, 0033, 0011. It means automatically, in this case, switch 2 will become the root bridge. So have a look and we continue. So you can check again 1 minute. I'll be back to you now. Let me put this guy, Monique. 1 second, I'm checking something. You can also compare the other one on top here. Okay, I'm going to allow this student in. Who want to log in? To log in. Um, 1 second. Yes, sorry. Okay, so we know how to elect the root bridge based on the lowest bridge ID. Now, there is a step number 2 will be elect the root port. Mhm. So we say first thing first, elect the root bridge. We know the rule for that. Now we need to elect the root port. The root port is what? So the root bridge, if you have a root bridge, the big boss, all the ports are automatically root ports. It's a root. They belong to the root bridge. Other guys who are not the root bridge, they need to elect a port that's called root port. So that port is the closest to the switch with a lowest cost. For example, to go to, I don't know, to town, it will cost me 20 rand if I take my city bus. If I take Uber, it will cost me maybe 50 rand. So which one are you going to take? You take my city bus because it's cheaper. So it's the same thing. So on each port, the port that is closest to the root bridge with a lowest cost. So for cost, we have the value of the speed of the link. We have a cost. So S3 is connected to switch 1. So S3 has a lot of ports. We need to grab one. So the link, each link has a cost. You see. So if your link is 10 meg, this is the cost 100. If your link is 100 meg, this is the cost. If your link between switch 3 and the root bridge, if the link, that link is 1 gig, this is the cost. And so this one is very important to know that. So now let's check to elect the root port. First thing first, we elect the root bridge. It's the big boss. Now we focus on other switches. So when you have a root bridge, all the ports on the root bridge are root port by default. Now, other switches, we need to elect one root port. It's based on the lowest cost to go to the root bridge. Let's take, for example, switch 2. Part 1, and let's say the cost is 19. So let's go to our table. So let's say we have 100 meg link. So let's say the link between all of them is 100. The link is 100 meg. So if I take switch 2 to go to the root bridge, if I use this way, So let's say I have two ports, no? These two ports. Or on switch 2, we have 5 ports. So this port facing the root bridge. This one, if I use it to go to the root bridge, it will be what? 19 times 1. I use only one link, you see. So the cost, the 19 times only one way. But if I use via F2, I will use path 2. You see, I'll use this one to go to S3, then S3 to go to S1. So I use two links. So if I use path 2, it will be 19 times 2. It will be 38. You see. So based on these two, the cheapest is this one. So I'll use path 1, you see. So now we're going to say F01 is the root port. So have a look on it, 1 minute, and we continue. Okay, guys, we know now step number 2. So a root port is a
Sorry, Mr.
port.
Mark. Sorry,
Sorry, yeah,
Mr. Mark.
yes,
Yeah, my name is Jacques. I just want to know. I see you give the number there, 19 times one. Where's that 19 coming from?
yeah, I did explain here that each link has a cost.
Oh yeah,
If
I
your
see.
link,
Yeah.
yeah, if your link, yeah, you see, if it's 100 meg, so in our case, it's 100 meg, all of them. So because 100 meg, then the cost is 19, you see. So it means from S2, if I use F1 to go to S1, I use only one link. So see 19 times only one link. If I'm on F2 and I want to go to S1, I use one link here, then another link. So two links. So 19,
Okay.
yeah, times 2.
Thank you, Mr. Mark.
Okay, welcome. And we take the cheapest one. It's the same thing for Uber. No? So when you order, there is how do you call it in English again? So the app will show you the way you should use. Let's say if you use uh, the way on the app, it's 100 rand, for example, to reach your destination. If you want to use another way, it can be higher, you see. So yeah, so sometimes you compare and you say, okay, let's use this way because it's cheapest for me, you see. So it's cheaper for me. So a root port is a port on a switch that is not a root bridge and has a lowest cost to go to the root bridge. No worries, it's the first time, it can be confusing, but we'll do it many times. So we are done. First thing first, root bridge, we know. Step number 2, root port. Now, what next? Step number 3, designated port. So you can read first, then 1 minute and we continue. 1 second, so you can continue reading. Okay, so every segment between two switches will have one designated port. The designated port on the segment, it has the lowest internal route path to yo, that's confusing. In other words, the DP has the best path to receive traffic leading to the root bridge. So if a port is not a root port, is not a DP, a designated port, automatically it becomes a block port. So let's see an example here. This is an example. Sorry, I made a mistake. So when you have your root bridge, all the ports on the root bridge are by default DP, designated port, not root ports. So when you have your root bridge, all the port on the root bridge are designated port. Root port are the port on other switches with lower cost to go to the switch. So if you have switch one, who's the root bridge, we all know that they are all the DPs. So it's fine. For him, it's sorted. Now, when you have switch one and switch two on this link, we need only one DP, one designated port. So between S2 and S1, we can see that on this link between S1 and S2, on S1, F01 is automatically designated port. It means the other one on switch 2, in this case, in this example, normally should be what? Should be a block port, but we already identify this port as a root port, so it's fine. We don't touch it. We don't touch it. This one is fine. We only have one DP. It's fine. The other one is a root port. It's okay. We cannot get DP here and DP down here. So now it means if we take S3 and S1, on S3, this one is a root port, and S1 DP, it's fine. We cannot get two designated port. Now we need to come to S3 and S2. Which one will be the DP? Let's check together. It can be a bit confusing, but we'll do some revisions on that, just because it's new. So Cisco, this is the trick for Cisco. First thing first, it's new because it's the first time you're seeing. But the more you read, the more you practice, you start getting used to. So now the deal is between S3 and S2. So now let's check. Let's check what this guy will. You can read for a few seconds and you continue. Okay, so now it means now the deal is between S3 and S2. One will be the DP. And if one is a DP and the other one it's free, then it will be a block or alternate port or a block port. So we are almost done in 5 minutes and we close. I'm trying to make it very, very simple for you so that. So now why F2 is the designated port? Okay, let's read. If a port is not a root port or a designated port, then it becomes a block port. We say alternate or block backup or alternate port and backup port are discarding or blocking, blah, blah, blah. In this picture, spanning tree, ST is spanning tree algorithm, the system has configured F02 on S3 as alternate port. Port F02 on S3 is in the blocking state and will not forward Ethernet frames. All other ports, okay. But we didn't explain why this guy is. So let's check the rules on top here. We say what? Every segment between two switches will have only one DP. Okay, so we know. Now, the designated port on the segment between two switches has the lowest root path cost to the bridge. Lowest. Okay, let's check. We say lowest. So, so when we say lowest, what do we mean? Let me check. The lower internal root path cost to a bridge, to a root bridge. So we come here. If I take F2 to go that side, normally it's 19 plus 19 is 38. So we say what? The lowest. But this one is not the lowest. If we take F02 on S3, this one is normally the lowest. Okay, I'm going to go and to double check for DP for you now. I'm double check properly. At least we know how to elect a root bridge. We know how to elect root port. And now we need to find the DPs, designated port. When you have a root bridge, automatically all the ports are DPs. Now, what will be the deal between these two? I'm going to double check properly for you. Okay, guys, normally that's all. That's all for this. What I'll do next, and so anything else is extra info that really we don't know. We don't need. We're going to exchange messages, and if it take more 10 minutes, 20 seconds, okay. The most important thing is when you have interconnected switches, how the STP will work. Step 1, elect the root bridge. Step 2, elect the root port. Step 3, elect the DPs. And step 4 is any other ports are in blocking state. That's all. Except that you see sometimes Cisco they add too much info. Then so my advice for you, if you know this, it's fine. That's all for this chapter, especially how this process works. Okay, let us keep it simple. That's all for STP, is to avoid loops. When you have a lot of switches interconnected, we need some rules. See. Any questions? Yeah, let's stop here for today. Any questions? We'll get some labs. If I come here, see, I was even looking for my STP stuff. So let me open this one and see. Right, we one I opened already. Alternate STP. Okay, let me check here. Let me check if here every segment between two switches will have one DP. Okay. So when the internal root path, it's what I'm going to check. Internal. You see, even here we didn't specify the lowest. You see, the DP is a port on the segment that has the internal root path cost to. We didn't say if it's the highest or the lowest. No, the DP has the base path to receive. Okay, I'll try to find out properly, so that we'll see why this one is. Okay, guys, let us stop here for today. Any questions? Okay, so if no other questions, then we are done for chapter 5. As you know, Saturdays, when we meet, we'll do revisions and we'll also do some packet trace. If I go to STP here, let me check by my side. Go root bridge, we know. Root port, we know. Let's see this one, root ports. Okay, I'm going to have a look because I did some research before. And yeah, I'll let you know. Okay, so if no other questions, then let me see some labs that we can get. Go up, labs. We have some labs on STP. Chapter 5 investigates STP loop prevention. So we'll do that. Okay, guys, thank you so much for today. Enjoy your night, and we'll be meeting again on Wednesday. Thank you.